Hello students, today we're going to learn section 7.2, Similar Polygons. Now this is a symbol for similar. So when you see this squiggly line, that means similar. In order for similar polygons to exist, we have to meet these two conditions. Corresponding angles are congruent. Corresponding sides are proportional. Now we learned the word proportional with 7.1. That's when you take a ratio of two parts and set it equal to another ratio of two parts. So again, corresponding angles are congruent, corresponding sides are proportional. Okay, so now let's talk about example 1. They say that triangle ABC is similar to triangle XYZ. So if that's the case, that means the corresponding angles are congruent and the corresponding sides are proportional. So let's take a look at the steps here. So it says, complete each statement. The measure of angle B, here's angle B, is equal to what? Well, what is the position of B? First, second, or third? Well, if it's second, that means the answer would be the measure of angle Y. So this would be the measure of angle Y. Again, corresponding means same position, second position, second position. In part B, they want us to find out what this side's going to be. So we said corresponding sides are proportional. So let's take a look at this. Here is BC to YZ, second, third, second, third. BC to YZ, BC to YZ. And then we have XZ. So first, third, and this would be first, third. So AC would be your answer. So that's what we mean by proportional sides. Corresponding sides are proportional. So BC to YZ equals AC to XZ. Alright, and since angle since angle Y is 78 degrees, we know angle B is 78 degrees. Okay, so next is determine whether the parallelograms are similar. So the first thing we're going to do is we're going to look at the sides. So when I do this, the top parts of our ratio, I'm going to discuss the left parallelogram. The bottom parts are going to be the right parallelogram. So let's take a look at this. BC to KL, top to top, top to top, equals CD to LM, right side to right side, equals AD to JM, bottom to bottom, AD to JM, equals AB to JK, left to left, AB equals JK. Now when we substitute the numbers into this equation, we're going to see that BC is 1, KL is 2, 1 over 2. CD is 2, LM is 4. AD is 1, JM is 2. AB is 2, JK is 4, 2 over 4. When we reduce everything, the sides are proportional. So going back up to top, it says the sides have to be proportional. Well, they are. They all equal the same number. It's 1/2. So the sides are proportional. Now we have to check for corresponding angles and make sure that they're congruent. Well, angle B should equal angle K if the parallelograms are similar. But angle B is not congruent to angle A because angle B is 120 and angle K is 100. So these two angles are not congruent. Therefore, parallelogram BCDA is not similar to parallelogram KLMJ. All right. Now example 3. They're stating that if triangle ABC is similar to triangle YXZ, find the value of X. So we have a diagram here. They're already saying that this triangle is similar to this triangle. Don't get confused with the word congruent. Congruent means they're the same size. But we're not saying they're congruent. We're saying they're similar. So that means the corresponding angles are congruent and the proportional sides, or I'm sorry, corresponding sides are proportional. So let's take a look at this. AC to YZ. Okay? Yellow to yellow. AC to YZ. BC to XZ. Bottom to bottom. Again, notice this is my first. Okay. So again, AC to YZ equals BC to XZ. So AC is X, YZ is 40, BC is 12, XZ is 30. Now what we'll do is we'll use the cross product property. So X times 30 is 30X, and 40 times 12. We could divide by 30 on both sides. So when you multiply and then divide by 30, X is equal to 16. And this should make sense. If we say this is 16, does it make sense? It does. Because AC should be smaller than YZ. YZ is the bigger triangle, AC is a smaller triangle. So this makes sense. The proportions make sense. That's it for today. Thank you.